Let's see DMA. The name itself says that it is direct memory access. So from the name itself we can guess some few things here. Till now whatever we have seen, the architecture is like this. Either the programmed or interrupt driven IO. For them the architecture was like this. We had some CPU and here the IO interface, and then here we have memory, right? So whenever some word has to be transferred between memory and IO device, if you observe it clearly, CPU has to play an important role, or CPU has to be always involved in the transfer, isn't it? So every word has to be taken from IO and has to be sent to memory, or taken from memory and has to be sent to IO, like that. Now if you watch this is a serious disadvantage, isn't it? Because CPU time is precious. Instead of doing something useful, if you involve CPU in doing the IO, it is going to be a waste of time, isn't it? So you just imagine this scenario. Let us say you are having an interactive display unit like a screen. Now when you see the screen, the entire whatever you see on the screen has to be refreshed for every second, right? So because let us say you are typing something, that has to appear on the screen, which means the display has to continuously change. That is an IO activity, right? The image that has to be projected on the screen will be stored in terms of pixels and bits in the main memory, and from main memory it has to reach the this display unit. Then if it has to come through the CPU, for every pixel CPU has to run a command, output command. It is going to take hell a lot of time. So instead of this, the next architecture which is proposed is DMA. So by using DMA, the name itself suggests that direct memory access. Who is going to access the memory? IO device, right? It says that CPU should not stand in between, right? So we'll have memory and we'll have IO, and CPU will also be there, but then it is not going to be in the center, which means CPU will directly give the bus access to the IO device, so that IO can directly transfer the data between memory and IO, right? So in order for this to happen, we are going to have a special IO interface which is called as DMA controller, right? So we'll have a DMA controller here which will be connected to the device. Got it? So we have a common bus, and the bus will contain three parts. One is address bus, data bus, and the control bus. But then this bus will be used by the CPU for some time, and for some time it will grant the access of the bus to this DMA controller. Now DMA controller will directly transfer the data from the IO device to the memory. Got it? So that is all about DMA. Now I'll tell you what are the various internal things required in a DMA controller, and then we can see what is the operation of the DMA. So for that reason, I've taken the diagram here, the block diagram, which will explain about all the parts. Now we have the CPU here and we have the memory here. So this is the main memory, the RAM. Okay, we have CPU, we have the RAM here, and similarly we have the DMA controller here. DMA controller is connected to the IO peripheral device, right? Now let's go one by one. Let's see from the DMA perspective what are the pins that are required by CPU. So see, CPU is going to have a lot of other pins, but now we are since looking at the CPU from the perspective of DMA, we are going to talk about only few pins here. So one pin is interrupt pin. So interrupt pin is going to indicate whether there is an interrupt or not. So there is a misconception here. Whenever I said that, I earlier told you that IO can be of three types. One is programmed IO, other is interrupt driven IO, and the other one is DMA. Now when we talk about DMA, it doesn't mean that interrupt is not involved in DMA. Got it? So interrupt is also involved in DMA, but then it is going to help us in a different way. Got it? Earlier, whenever there has to be a word transfer, we have to get an interrupt and as a result of the interrupt we will be transferring a word. But here, whenever there is a request by the IO device, we'll again get an interrupt, but as a result of the interrupt, will trigger the DMA controller, and now DMA controller will take over and it will transfer. How is it useful compared to the interrupt driven or programmed IO is? We shall come to that. Okay. So for now, we have interrupt there, and then two pins. One is called as BG and BR. These are very important pins coming to the DMA. So BR means bus request. So bus request means we are going to have the common bus, right? The data, address and control. So bus request will come from the DMA controller. It is saying that whenever this bus request is one, it means that I have the data ready. If you just give me the control of the bus, I'll transfer the data. And bus grant is a signal originating from CPU and it will go on to the controller. This particular bus grant signal says that yes, if you have data, I am giving you the bus. Now initially our DMA will raise the signal bus request saying that I am ready to transfer the data, and then if you are ready, you are supposed to release the bus. So we should understand something here. When can you release the bus? So if you look at the instruction cycle, I told you that an instruction cycle will contain various phases. So what are the various phases in instruction cycle? So the different computers have different phases. It is not fixed. Most of the computers will follow whatever I am saying, but then it may vary from a computer to computer. It is not a static thing, right? So in instruction cycle will contain, one is fetch the instruction. After fetching, we decode the instruction, and after decoding, we fetch the operands and probably execute the instruction and then write back. Let us say we have all these 5 phases in an instruction, right? Now whenever we get an interrupt, when are we going to process it? We might get the interrupt signal anywhere during the instruction cycle, but then we are supposed to address it only at the end, only at this point, right? So this point, it is called as interrupt break point. Interrupt break point is nothing but when are we actually going to stop the execution of the CPU or the current instruction and dedicate the attention to the interrupt. So only after executing the complete instruction only will always address the interrupt. We are never going to stop the instruction in the middle and go to the interrupt. Okay, we'll complete it completely and then we go here. But then DMA is different. In DMA, whenever you get the bus request, see, interrupt will be given here, but then whenever there is a request for the bus, you can grant the bus by sending out the bus grant signal at the end of every cycle. Got it? So any of these places, all these places, whenever there is end of a cycle, you can decide whether to give the bus or not. So DMA breakpoints can be anywhere. So by this I mean to say that if you have just finished fetching the instruction, then you can leave the bus to the DMA. DMA will use the bus for some time and again give you back the bus. Then you can continue with the decode phase, or while performing the decode phase, if you get the bus request, right, then you can grant the bus or immediately after finishing the decode phase, right? Which means even if you disturb the execution of the instruction in the middle of the instruction, you will not be facing any consequences, any bad consequences. But then when you give the control, or when you stop the execution of a instruction to provide the service to an interrupt, many things may go wrong, because the reason is when you stop in the middle and if you start the interrupt service routine, then there is a chance that your interrupt service routine will change the registers internally, because of which whatever has happened till here for the instruction may be lost. And moreover, once you stop an instruction in the middle, you cannot come back and start the instruction from this phase. You have to again start it from the beginning. But then if you simply leave the bus for some time, you are actually halting the CPU or just stopping the CPU for some time, and whenever it resumes, it will resume immediately from the next cycle here. Got it? So this is the major difference, right? Okay, one more thing. You might be scared by seeing this big diagram. You need not by heart it at all. I'm just taking it to make these things understandable. It doesn't mean that you have to by heart it all. If you can just understand how it is working, if you see, that is the beauty of the concepts. So once you understand the concept, you need not by heart them, but there are facts. See, I think you know the difference between the facts and concepts, right? Facts means you have to remember it, you have to by heart it. For example, if you take any biology subject, let's say, they'll have a name for every bone, right? There'll be no reason behind why that bone is named as such. They'll not call it as a hand bone or leg bone. They'll have a separate name for that. Every bone, you are supposed to by heart those names. There'll be no reason behind it. Even if there is a reason, they'll say that it is some Greek name or something like that. But coming to a concept, once you understand it, you need not by heart it, right? So here, the main intention of taking this diagram and explaining everything is to make the concept clear. Once you understand the concept, you need not by heart it. Okay, so don't worry about this big diagram. You are not going to by heart it. It is not required. Just try to understand the concept. We'll apply it to the problems. Okay. Now we are discussing about CPU, right? Yes. Coming to the CPU, these are all the things we have. One is interrupt. As usual, you know why interrupt is used. Whenever an IO device requires something, it will raise an interrupt. And see, whenever you raise a, IO can be initiated by the CPU or by the IO device. If it is initiated by the IO device, you will get an interrupt. If it is initiated by the CPU, you will first contact the IO controller, and IO controller, if it is not ready, it will interrupt you when it is ready. So both ways you are going to get an interrupt from the IO device whenever it is ready to transfer the data, right? Now, as a reaction here, you are going to process or service this interrupt by initializing the DMA. Now, how are you going to initialize the DMA is, you will tell the DMA what it is supposed to do. Either it should write or it should read, right? So if you want to write something from the IO device, IO peripheral into the memory, then you have to give the signal, you have to write. If you have to read something from the memory, write means if you have to send something from the memory into the peripheral device, we have to say write. If you have to read something from the IO device into the memory, you have to say read. Therefore, these two are the control lines which, if they are given by the CPU, means that what is the action this particular DMA has to take. Otherwise, these two signals can even be generated by the DMA controller so that depends on it. So which means whether CPU is using these signals or generating these signals, or DMA is generating these signals, will depend on what is the status of the bus. If the bus is not granted to the DMA controller, it means that CPU is telling DMA to do that work. If the bus is already granted to the DMA controller, which means if, let us say, DMA has requested the bus, which means here it has kept 1, and then it has got the bus granted, which means here we got 1. Now if read or write is set here, it means it is the signal which is generated by the DMA controller, and that signal is supposed to be given to the main memory. Got it? So try to understand this one. Simple. Now we are going to have control lines, and if you see the control lines, they are in this case, they are only read and write control lines, and these three control lines are shared between three parts: CPU, DMA controller, and the main memory. Now what is the meaning of these two lines will depend on what is currently happening there. If DMA has not raised the request, and if DMA is not granted the system bus, then it means that CPU is telling DMA what to do, whether to read or write. Okay. In case if DMA controller has asked the bus and if it got granted, if the bus is granted to the DMA controller, then in this case it means that DMA is using these controls to tell the memory whether to read a word or write a word. Got it? So the meaning depends on what the current scenario is. Okay, so these two lines are the part of the control lines, and then you know what the address line is. Okay, address bus, this is address bus, this entire line is address bus. Again, if you see the address bus is being used by CPU and the DMA controller and the memory. Again, the meaning of the address bus will depend on what the signals are. If the bus is not granted to the DMA controller, it means that bus is still under the control of CPU, and now CPU is generating the address. Now why will CPU generate addresses? There are various reasons. One reason is CPU is generating the address to select the DMA controller. So what it will do is it will send the address, and that address will be given to the address select, and using the address select, DS means this particular device will be selected, device select, and then RS means register select. So if you look at this, there are various registers inside this. One is address, and the other one is data, and the other one is, there will be one more register which is called as count, word count. Okay, so there is going to be address. I think in data itself it is going to contain the word count. Okay, there is no need of this. Okay, so now depending on what register is in this bit is, either this one or this one is selected. So what is the purpose of this bus, this address is, first our CPU will select the DMA by using these two, and then it will select one of these registers. Now if this register is selected, it means that we are specifying the address from which we have to read from the memory or to which we have to write in the memory, right? So try to understand this. Whatever is happening here is we are trying to initialize the DMA controller to proceed further. So if DMA controller has to transfer some words from IO device into the main memory, what should it need? It has to know where to write or where to read from the main memory. For that reason, we'll first send the address to select this particular device. After selecting the device, through the data bus, we'll load this address register. Now this address register, this particular address register will then contain the address at which it has to access the main memory. Got it? And along with that, we have one more bus which is called as data bus. Now from data bus we have again collected here. So I don't think that it is appropriate, or you'll understand by writing like this. Assume that there are two registers here. One is called address register and other is called word count. So by putting address register, you'll again get confused. Let me put it this way. So IO address or memory address, IOA, something like this. So this means that it is a register which has to hold the address where IO device has to contact the main memory, right? And along with that there will be word count. Got it? Okay. Now by using this particular signal, first this device will be selected, and then by using this particular register select, one of these two registers will be selected. Got it? And once they are selected, CPU has to initiate these two. Now what is the meaning of each register is, whatever address you load into this register, this is the address from which you are supposed to read or write into the main memory. Okay, here address, the address at which you want to do the actions, either read or write. And next one is word count. Word count is how many words you want to read or write from the main memory. These two will be initialized. So once you got initialized, then your DMA will be ready to act. Got it? So now what is happening here? See, whenever you get an interrupt, you are supposed to initialize your DMA. As a part of initialization, CPU will tell DMA whether to read or write. In case either it is read or write, it will also say from which address we have to read or write from the main memory, and it will also say how many words you are supposed to read or write from the main memory, right? So initialization will be over. After initialization, it is up to the DMA controller to request the bus from the CPU whenever the data is ready for the transfer. Now, how will it know the data is ready for the transfer? That will be known from the IO device peripherals. So once you have initialized everything, then CPU will go and do its own work. It will be executing some instruction. Then this particular DMA controller will keep on waiting for the IO device to make the data ready. So whenever data is ready by the IO device, it will say, yes, I am ready, by sending DMA request. And whenever DMA gets the signal that data is ready in the IO device, then DMA will raise the bus request. Now that bus request will go to the CPU, and CPU will give the bus access by giving the bus grant. Now this bus is under the control of the DMA controller. Now how will you know that bus is under the control of the DMA controller? By seeing these two lines. As long as bus grant is 1, it means that bus is granted to the DMA. Got it? Now when bus is given to the DMA, now DMA will put the address where it has to read or write the memory. Let us say we have to write some word from the IO device into the main memory. In that case, from this IO register, it will give this data to the address bus. Now that address bus will go and select that particular word in the main memory. Got it? At the same time, it will say write signal, which means you have to write something into the memory. Got it? So this particular word, let us say some word is selected and it is ready to be written, right? At the same time, from the device is directly connected like this, data bus, right? So from the device directly main memory will be connected and the word will be written. Got it? So what happens after that? Once you have written a word, what happens is the address, let us say you have written at the address 100, then immediately this address register will be incremented to 101, which means next word has to be written, and the word count will be reduced to word count will be reduced by 1. So let us say it has initially, our CPU has initialized the DMA controller's address register with 100. What does it mean? You have to start writing from word number 100, and let us say word count is initialized to 10. What does it mean? It means that you are supposed to transfer 10 words from the IO device into the main memory, right? So whenever the word is ready in the IO peripheral, see, that is the advantage. CPU is not doing anything here. CPU is executing its own instruction. So, and our IO device is very slow. That is why whenever IO device is ready, it will send a request, and whenever the request is received by the DMA controller, it will ask for the CPU for the bus, right? And till then CPU is doing its own work. Now whenever CPU gets the request for the bus, it will grant the request saying that yes, you are given the bus access. Now whenever it gets the bus access, DMA will immediately put whatever address is required, at whatever address we want to write that on the address bus, which means that particular word will be selected. At the same time, it will say you have to write or read. Let us say in this case we are writing, so write will be 1, so which means write signal will be selected. So this word will be ready to be written on, right? And at the same time you are supposed to provide the data. For that reason, it will say DMA acknowledgement will be sent from here, which means yes, now you can put the data on the data bus. Now IO peripheral will put the data on the data bus. Now that particular data will be sent into the memory here. Immediately after doing that, our register will be incremented by 101 and it will be decremented by 1 word, which means we are initially supposed to transfer 9 words, out of which we have transferred 1 word, and so we are supposed to transfer 9 more words, right? But then your IO devices are generally slow, and so immediately you will not be given the next word, and till that time our DMA controller will release the system bus. How? By making the bus request as 0. So whenever it sees the bus request as 0, CPU will make bus grant 0, which means CPU will take the buses, right? So whenever CPU takes the control of the buses, it means that CPU is ready and executing its own program. Got it? So again CPU will be executing its own program from wherever it has stopped earlier in the previous time, right? So now what happens is, whenever it is again one more word is available here, again our DMA, our IO peripheral will send DMA request, and DMA request will lead to bus request, and bus request will be sent to the CPU, and CPU will say yes, bus grant, and whenever bus is granted 101 will be pasted on the address, and that particular address means the next word will be selected and write will be selected, which means the next word is ready to be written, and at the same time DMA acknowledgement will be sent. Now the next word will be kept on the data bus and the next word will be written, and after every transfer we'll either increment or decrement the address bus. That depends on whether you are writing it like this or like this, that depends on you, right? In this case assume that it is incremented, and always word count is decremented, right? So it will keep on happening, and whenever it becomes 0, which means CPU has initially asked our DMA controller to transfer 10 words, and after it becomes 0, it means it has transferred 10 words, it will again raise the interrupt saying that my task is completely done. Then CPU will read the status register here. So there are various registers, one of the register is status register. Now this status register will say, the status register and the word count register, both of them will say whether the transfer is completely done, or in case if the transfer is not completely done but still you got an interrupt, then it means that something wrong has happened. What are the various things that might go wrong is, while transferring some data there might be some bit errors, so that will be indicated by CRC, right? Or you might have given the work to DMA controller, and DMA controller might be waiting for the IO peripheral to perform the action and provide the data, but even after waiting for the IO peripheral might not respond at all to the DMA controller. Then in that case DMA controller will tell the CPU that, see, I have been waiting for a long time and the device is not responding, so there is something wrong with the device. So that is also an exception condition, got it? Further timeout will be used. So anyway, at the beginning, at the end, at the ending, interrupt will be raised, and our CPU is supposed to service that interrupt by initializing this or by checking the word count at the end, got it? Now what is the main advantage of using this mode is, okay, before going to the advantage, generally this DMA controller will be operating in two modes. So one mode is called as burst mode, and the second mode is called as cycle stealing mode. So burst mode means if you are talking about a device which is very fast, like a hard disk is very fast, so whenever one word is available, and by the time you transfer one word, the second word will be available right away. Therefore our DMA controller, whenever it takes the bus, it will not get a chance to leave the bus at all or to release the control of the bus. Therefore it will continuously have bus request as 1, right? And therefore you'll once you get the bus, it will not leave the bus until the entire data has been transferred in a block, right? So since you are transferring the data continuously without leaving the bus, why are you not leaving the bus? Because the data is coming very fast, right? In that case, that particular mode of transfer is called as burst mode. Now what is the advantage of this burst mode? The transfer is fast. What is the disadvantage of the burst mode? As long as DMA is using the bus to perform this particular actions, the transfer, our CPU will be completely blocked, because in order for the CPU to execute, it has to fetch the instructions from the main memory. In order to fetch it, it needs the system bus, but then system bus is now taken by the DMA controller. Therefore for that entire period of time, our DMA controller is using the bus or it is blocking the CPU. So that is a disadvantage. Now the second mode is cycle stealing mode. And coming to this cycle stealing mode, various textbooks have different textbooks have different ways of saying about this. Some textbooks, they say that cycle stealing means using the system bus whenever CPU doesn't need it. For example, if you are looking at all the phases, in the fetch phase we need the system bus, but in decode phase we don't need the system bus. in operand fetch phase we need the system phase, but in executing we don't need the system bus. And similarly in the write back we need the system bus. If you are trying to write back the result of the operation into the memory, we need the system bus. Therefore out of these 5 cycles or 5 phases, 2 phases don't need the bus. So some textbooks say that if you configure your DMA in such a way that it will take the control of the bus whenever CPU doesn't need it, then if CPU is not using the bus, then it need not even inform the CPU, right? So which means it is transparent. So some textbook says that cycle stealing is nothing but the transparent way of taking the system bus whenever CPU doesn't need it. And some textbooks they say that cycle stealing means asking the CPU for this cycle and CPU will grant you the cycle, then our DMA controller will transfer only one word, which means it will use the CPU, the bus, for only one memory cycle, and then it will immediately give it back, and then CPU will use it for some time, and after some time again our DMA will use it. So there are these 2 ways of saying it. One way of saying is whenever CPU, some textbooks say that whenever CPU doesn't need the bus, then our DMA controller will take it and give it back without letting the CPU know. That is why they are calling it as cycle stealing, right? Other textbooks say that no, CPU will be asked the permission, but then CPU will give it only for one cycle, or our DMA controller will use it only for one cycle and release it. So generally this type of transfer is apt for the slower devices like keyboard. If you are typing something on the keyboard, you will not be typing at a rate of 1000 characters per second. You will be sending 1 or 2 characters per second. In that case, in every second it will ask for one cycle. Got it? So that is where CPU, the cycle stealing is going to be useful, right? So anyway, what I mean to say is DMA is far more efficient compared to any other mode. The reason is simple. Initializing is very simple, right? It is not a lot of work. Once you initialize it, for all the words, it will not disturb you much, right? If you look at the interrupt driven IO, for every word you have to get an interrupt, and for every word you have to go through the overhead, right? Interrupt overhead. But here, initially you set it up once, and then the data transfer will happen very fast, and it will happen only when the data is ready. Alright, so later we shall compare this, and when we shall see why it is useful and all in numerical examples. But I hope that this has given you some overview about this DMA, right? So to summarize this, what are the actions that are going to be taken? First, we get an interrupt. As a result of the interrupt, we are going to initialize all the various things required in the DMA controller. Got it? So once we initialize it, then we go and execute our program as usual. Whenever data is ready from the IO peripheral, it will say the DMA that data is ready. Then DMA will ask CPU for the bus. CPU will grant DMA the bus. Then CPU will put the address here and whatever control is required, and then ask the IO device to transfer the data, and it will keep on transferring it. And this will keep on happening depending on the speed of the IO device. If the IO device is very fast, then a burst mode type of transfer will happen. If the IO device is very slow, then a kind of cycle stealing will happen. Got it? And anyway, both the ways there is only one initialization and then one ending, so it is not actually disturbing us a lot of times like in interrupt mode. In interrupt mode we will be disturbed for every word, but here we will be disturbed only in the beginning and at the ending, and all the entire transfer will happen very fast without disturbing it, right? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join DMA visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.